algebraically or by hand, manually, however you want to call it. Does anybody remember the definition of what a quadratic function is? The word quadratic. It's for second degree polynomials. Okay. And does anybody remember the shape of our quadratics? Here's my x-axis, here's my y-axis. In fact, it has a parent function just like the absolute value, right? It has a parent function, and that parent function is y equals x squared, quadratic, power 2, right? Does anybody remember the shape? It's it's a U shape. It's what we call a parabola, right? Okay, and the vertex is at x equals 0. In fact, there's a line of symmetry here. In the parent function, it happens to be the vertical line x equals 0. It's our line of symmetry. Okay, x equals 0 or the y-axis, right? Now, in this course, we will also be looking at parabolas that open downwards. Just, excuse me, just realize the parabola can open up sideways, but we're not going to look at it in this course. Okay? We're only looking at parabolas that open upward and downward. And don't forget, um, they have all the transformations as the absolute value function we just did, right? They can shift to the left, they can shift down, they can stretch, they can compress, they can reflect. So all of those transformations we learned in the absolute value function, we're going to apply to the quadratic function as well. And like I said, we're going to be looking at all those transformations the entire year. So we have other functions we're going to be applying those transformations. That's why I spent so much time on them. Okay. The first form we're going to be looking at is the standard form. Okay. And we worked with this. I spoke about it when we were doing some factoring, right? That standard form is y equals ax squared plus bx plus c. Okay. Now, the a, b, and c here are actually coefficients of the variable x. And you're probably saying to yourself, well, this is in standard form because the exponents of the variable are in descending order, and there is actually a variable with the c, the constant. There is an x there. It's just raised to the 0 power. Okay, that's why we don't put an x there. But it's in descending order: 2, 1, 0. A, B, and C are the coefficients, and you probably remember this from um, algebra 1 when you had to do the quadratic formula, like 100 problems they give you, and you have to do all those. Yeah. So, in order to graph our parabolas or any function really, you need at least 3 points. Okay? Like I said, we're not going to do the calculator today. The absolute value function, I did use the calculator first, then went to the algebraic way. For the quadratic function, we're going to do the different algebraic ways first, and then I'll show you at a later date how to do it on the calculator. Okay. So in order to graph a function manually or algebraically, we need at least 3 points. And these are the different steps with the different forms. We're looking at standard form now. We're going to look at vertex form and then intercept form. Well, to get our 3 points for standard form, the first point we're going to get is the vertex. Okay, and we're going to get that. See that line of symmetry? It's going right through our vertex. So we're going to find that line of symmetry, which is nothing more than just x equals a number. And to get that x coordinate for the symmetry, we use this formula. Okay. So that gives us, step one gives us the x coordinate of the vertex. And I'm using the coefficients of my equation, negative b divided by 2a, that gives me that x coordinate. I have to figure it out algebraically. Okay, once I get that x coordinate, so that vertex, this is going to give me the x coordinate. I still have to find that y coordinate, right? So this next step, step two, is going to give us the y coordinate of the vertex. Okay? And all we do for that is, well, we take our x, we go back in, substitute it into our original equation, and that will give us the value for y. So at this point, I'll have my vertex x comma h. So there's my first point. I need 2 more points, right? So that's what step 3 does. I'm going to use my t-chart, and I have my vertex point. My vertex is, I already have it, is x comma h, whatever it is. And here's the nice part about having a line of symmetry. Remember we had a line of symmetry with our absolute value functions? Where if I chose one, I'd like to use one smaller, and that smaller than x, so x minus 1, and one larger, x plus 1. If I use the same distance for these x values, the y's are going to be the same. Remember, just like the absolute value function.
So how do we get y instead of
I'm sorry?
how do we get y instead of
Well, we got the vertex, right? Are you good with finding the vertex? Okay, so I'm going to choose an x number because x you choose, it's independent. I like to use one larger. Like if this is 2, I'll use 3. If this is 2, I'll use 1 smaller. That way, all I have to do is plug in this x into my equation to get this y, and this y will be the same as this y because I have an axis of symmetry. So I only need to find 1 point. If I didn't use the same distance, one smaller, one larger, I would have to do this twice. Oh, excuse me. Okay, it's a good question, by the way. So there's my 3 points. Put them on the graph. Draw my parabola. And we're going to go through examples of each one of these. So I know it sounds confusing. Hopefully, after we do our examples, it'll clear up. The next one, vertex form. Now, vertex form, you're very familiar with, right? Because we just did it graphing the absolute value function. And it actually is kind of easy because the vertex is at h comma k. Vertex form, remember, a times the mathematical symbols, x minus h, in this case it's squared, plus k, where the same transformations, right? A is the slope. Remember, the slope has three transformations. If it's negative, it reflects. If it's greater than one, stretches. If it's a fraction between um, 0 and 1, compresses. Our h, the transformations on those, shift left or right, and it's opposite the sign, right? And the k was up or down, follow the sign. Those were our, let's see, 3, 4, 5 transformations. It's going to go throughout the course. You gotta learn those transformations. So the vertex, well, that's steps 1 and 2 for the standard form. So we already have our vertex here, our HK. So this is a lot easier because we can just read it right off of the vertex form. A lot less algebra here. Okay, but we do have to find 3 points, right? We have our vertex, which was HK. We still have to find 2 other points. And again, we really only have to find 1 point, right? If I go one greater, one bigger, and one smaller. Or you could go two as long as you keep it the same. If you want to go two smaller, make sure you go two bigger so that you have the same y. That way you only have one algebraic equation to solve. Make sense? You should be pretty familiar with both these forms by now. The one that you're not going to be familiar with, intercept form. And there's a couple of reasons. First of all students hate factoring. Very few students love factoring. It's very seldom do I get a student in, hey, Mr. D, factoring's so much fun. Can we just do that for the rest of the year? It hasn't happened once to me in 12 years here. So a lot of teachers and a lot of students, especially students, steer away from the intercept form. It's really nice to have intercept form when we're doing mathematical modeling problems that we're going to be doing next week. Okay? Because it gives us the zeros of the equation, the roots, the solutions, the x-intercepts, all those different names. There's different names for them because there's so many different real life situations that use the x-intercept form. Okay? This is probably the most real life math that you're going to use. All right, just like we did when we were factoring, the form is y equals a times the quantity x minus p. This time we're using p's and q's. X minus p times the quantity x minus q. Now, this is just like the factoring we did, right? Where we had, I don't know, x minus 2 and x plus 3, right? We factored and we got those factors. Now, some of them obviously weren't that easy. There were some pretty hard ones we did, especially on the quiz, right? They're just using the P and the Q, just different letters of the alphabet, um, just to be different from the X's. Okay. To find the X intercepts, by the way, what are X intercepts?
The line crosses that fence.
Yes. Ooh, who said that? Very good, Caleb. That is awesome. Yeah, it's where those points are crossing the x-axis. So suppose I'm working with a parabola here that's crossing that x-axis like this. So I get these 2 points, right, that are crossing. Well, one's P and one's Q. That's what they mean by the P and Q in our formula here. All right. Now, don't forget our parabola has a line of symmetry, right? That goes through the vertex. So all this information we're going to use for intercept form. How do we get these P's and Q's? How do we know what points these are? Well, we take our factors. In this case, we take our, and again, I put numbers in here because it's easier, more helpful to see. We take our factors and we set them equal to 0. So I'm going to take that x minus 2, set it equal to 0. Add 2 to both sides, so my x-intercept here is positive 2. If I were to take this factor, set it equal to 0, my x-intercept would be negative 3, right? Notice that they're just opposite the signs. Negative 2, positive 2, positive 3, negative 3. Inside the math symbols. Again, keep that in the back of your mind. Now, you could probably skip this step, setting them equal to 0, for simple factors like this, right? But remember, we on the quiz, we had some factors that were like 2x plus 5 times x minus 1. You might have to actually work these out because 2x plus 5 equals 0. Well, first you would have to subtract 5. You actually get a fraction. 2x equals negative 5, divide by 2, divide by 2. So x coordinate would be negative 5 halves. So they can get complicated. But if you have simple factors like this, just take opposite the sign. Okay, so that gives us our x-intercepts, our zeros, solutions. You're going to hear a lot of different terms for x-intercepts, but they all mean the same thing, where it crosses the x-axis. Okay, now this point, this vertex point, that remember it's a vertical line, so x equals that number. Well, to get that number, that coordinate for the x vertex, we use this equation, which is nothing more than taking the average of p plus q and dividing by 2. So we're looking for the average there, right? The middle point. And once we get an x equals a number, and once we have that number, well, to get the y, we're going to plug it back into the equation and get our y value. Okay, so I know it sounds complicated for the intercept form, but it's actually, when we see it in action, it's not that bad. And it's really one of the most common real life situations that you have. Ready for some examples? So I'm going to just put on here, substitute back in. To get the y value. So with all your notes now, you should be able to graph a quadratic function without touching a calculator, no matter what form you're given. All right, let's start with number one, standard form. When I have when I'm given a quadratic equation in standard form, the first thing I'd like to do state what my A, B, and C is. It's a habit for me. You don't have to, but I think it's a good idea. My A is 2. My B is, I got to watch the sign this time, -4. And my C is 3. So that's step one says I have to find the X coordinate, right? Step one, I have to find the X coordinate using of the vertex using this formula. So I have to find the X coordinate using -b divided by 2 times A. Okay, -b, my b is -4, all divided by 2 times A, which is 2. So this gives me a +4 over 2 times 2 is 4, which is 1. So the X coordinate of the vertex, bless you, is 1. X coordinate of the vertex is 1. The X axis of symmetry is that X coordinate, X equal 1. So I'm going to go ahead and put the line of symmetry in here. Okay, there's my line of symmetry to X equal 1. Okay, now I need to find the Y value of the vertex, right? Well, I know what the X value is, so I'm going to substitute the X value back into the original equation. I have Y equals 2, I'm going to substitute in 1 for the X, squared minus 4 needs a substitution for the X, plus 3. X coordinate is 1. X is 1. 1 squared is 1. 1 times 2 is 2. Minus 4 times 1 is 4. Plus 3. So my y coordinate for the vertex is 2 minus 4 is -2. Plus 3 is +1. So my y coordinate is +1. Vertex is at 1, comma 1. All right, so I'm going to pick one larger. I'm going to pick 2. And because I want one larger, I want one smaller. I'm going to pick 0. Okay, so I'm just going to take one of them because I picked the same distance. I only need to solve one of these x's because the y's are going to be the same. I'm actually going to use 0. So y equals 2 times x squared minus 4 times x plus 3. This time, I'm using 0. I'm choosing the 0. And look what happens to these terms. They cancel out, right? So my y equals 3. My y equals 3. It's going to be the same as this one. So I have 0, 3 and 2, 3. And there's my parabola. As we say in the COVID era. Just kidding. Parabola. Okay. Any questions on how to graph a parabola, quadratic function, in standard form, doing it algebraically. You guys are going to all remember this tomorrow, right? Okay, let's do vertex form. Now, vertex form should be pretty easy because you guys are used to this. Just took a test on it yesterday, right? All right, vertex. That should be easy. HK. Okay, so my vertex here is, remember, opposite the sign for my H is positive 4. Same sign for the K is 3. So my vertex here, 4 comma 3, which means my axis of symmetry is x equal the x coordinate 4. So let's go ahead and put that on our graph. Vertex 4 comma 3, axis of symmetry is x equal 4. There's my line of symmetry. And I need 2 more points. Well, if I go up 1, 5, go down 1, 3, I'm going to use a 3. So let's see, I get y equals parenthesis, I'm going to put a number in for x, minus 4, parentheses squared, plus 3. And I'm going to put, I said I was going to use a 3, so I'm going to use a 3. So I get 3 minus 4 is negative 1 squared plus 3. Negative 1 squared is 1. Add 3. So my y equals 4. 4 here will be the same as 4 here. So there's my 3 points. 3 comma 4 and 5 comma 4. And you guys could have cheated here, right? From the absolute value function. Remember, our A was 1, 1. How we graphed them, right?
This is your reminder to go sub.
Okay, yeah, I got it. Thank you. They sent me a roster. So.
Okay, everything else is already over there, but I forgot to put those in there, so I'll just hand it to you.
Okay. See you later. So if we used, remember, our A here, right, was 1, 1. Remember when we used the absolute value function? We just went from the vertex up 1 to the right 1 and up 1 to the left 1. We could have cheated and not done any of this algebra. But you know me, I like doing extra work. Nothing? I get nothing? All right, last one. Intercept form. Okay, they actually gave it to us in intercept form, right? If we set those equal to 0, that'll get us our x-intercepts. So subtract 3, subtract 3. So x equals negative 3, add 5, x equals positive 5. So our x-intercepts, we could have just taken the opposite signs. Negative 3, 5. Pretty easy, right? Axis of symmetry, we have to use our equation. The x-coordinate is the average of P and Q. P plus Q divided by 2. My P, negative 3, plus my Q, 5, divided by 2. So I get negative 3 plus 5 is positive 2 over 2, which is 1. So my vertex, I have the x-coordinate, 1. My axis of symmetry is x equal 1. So here's 1, Here's my axis of symmetry. Okay, I have my P and Q. -3 crosses the x-axis at -3, crosses the x-axis at 5. I forgot to put those points on there. So I have 2 points. Halfway through the third point, I just need this y value. So I'm going to go up and pick up my equation. Y equals, and again, I'm going to substitute in for x, plus 3. X, I'm going to substitute in for x, minus 5. My substitutions, well, I know that x is 1. So I get 1 plus 3 is 4. 1 minus 5 is -4. So my y is going to equal -16. So there's my y coordinate, -16. So my vertex, 1, -16. And now I can draw my parabola. This is my x equal 1 axis of symmetry line. Oh, look at that. That's a pretty good long curve. That one, not so much. So there's my parabola, or in the day and age of COVID, parabola, using the intercept form. Now, wasn't that fun?
Why didn't the 3 and the 5 subtract in their original?
I'm sorry, what?
Why did the 3 and the 5 subtract?
I can't hear you.
Why did the 3 and the 5 switch